All right, Algebra 1A students, welcome to part 3 of lesson 6.3. We're still talking about the elimination method for solving systems of equations, but in this video we're going to have to multiply both of our equations in order to see one variable get the same number in front in the two equations for one of our coefficients to match up. These are a little bit harder. Therefore, what we're doing today in terms of practice problems and these kind of problems on quizzes and tests, things like that, will be extra credit. But I want you to see how it works. I do think it's something that we're capable of doing, but it does add just another step that may lead to some math issues. So just be aware of that going into this, and we'll get started here. If I look at this system of equations right here, 3x plus 2y equals 1, 4x plus 3y equals negative 2, I want to notice that neither of my variables, x or y, have the same number in front. So this is not in a system of equations that is set up very well for elimination. And to further complicate this, neither 3 nor 2 can be multiplied by anything to turn into 4 or 3. That would match them up with the other number on the variable in the other equation. So I have to think about which variable do I want to eliminate, and then multiply both equations to make the coefficients on that variable the same. Now, you can choose whichever variable you want to eliminate here. I'm going to choose to eliminate the x variable, which means I want to turn the 3 and the 4 both into the same number. The easiest way to do that, like finding a common denominator when we're adding fractions, is to just multiply by the other number. So if I multiply the 3 by 4, I get 12, and if I multiply the 4 by the 3, I also get 12, right? So if I multiply both of those, I get 12x, and the other equation also has a 12x. So, oops, there we go. So now that I have the x's the same, I do have to remember that the entire equation is supposed to get multiplied by this number, not just the piece I'm trying to eliminate, but everything in that equation has to get multiplied. So I'll have to do 4 times 2y's and 3 times 3y's and 4 times 1 and 3 times negative 2 to finish out my two equations here. So what I end up with in the top equation is 12x plus 8y equals 4. And in the bottom equation, I have 12x plus 9y equals negative 6. Right? Because I multiplied all of those by 3. Multiplied the entire top equation by 4, the entire bottom equation by 3, and I end up here with these two equations. Now I have the same coefficient on my x variable in each equation. So this is what I'm going to be eliminating. I'm going to be eliminating the x's, and because they are both positives in front of them, I will subtract 12 minus 12 will go away and get 0. Then I'll subtract the rest of the equations and see what I get. In terms of my y variable, I have 8, and I'm taking away 9, which leads me to negative 1y. And in terms of numbers, I have 4. Take away a negative 6. 4 take away negative 6 is actually a positive 10. So I get negative 1y equals 10. And if I divide by negative 1, that goes away. I divide this one by negative 1. I get that y is equal to negative 10. Okay? So now I have half of my answer. I know that y is equal to negative 10. And now what I'm going to do is I'm going to put that back into one of these two equations, probably one of the two that I started with back up here, and try to solve for my x variable based on y being negative 10. So I'm going to choose to put it into the first equation, but you're certainly welcome to put it into the second equation as well. Doesn't matter. But if I put it in the first equation, the top equation originally said 3x plus 2 times y. But now I know my y number is a negative 10. So I'm going to multiply 2 by negative 10, and that equals 1. So this is the equation that I'm going to try to solve to find, whoopsies, to find my x variable, right? So make that a little bit bigger, and if I multiply here, 2 times negative 10 makes negative 20. 3x minus 20 equals 1 is what that equation says. If I add 20 on both sides, plus 20, I get that 3x is equal to 21. Dividing by 3 gets me x equals 7. And now I have my final system, 7 comma negative 10. Right? So this system of equations, the process once I had the same value on the variable is exactly the same as it used to be. We eliminate by subtraction because they were the same sign, and then I find one of my variable values, plug it back in, find the other one. Okay? The only thing that's difficult here is figuring out what variable do I want to eliminate and what number do I have to turn them into in order to do that. All right? So if you have questions about this double multiplication of both equations, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.